Hello there. In this lesson, we will learn how to use the exponent rule and property to do problems. So first, let's see the definition of exponent expression. It looked like this, a to the n. So a, they call the base, using the base of bottom, and then n, they call the exponent. And so first thing, before we look at the other rule, so we're going to do this one here. So I have a to the third times a squared. So this one is meaning a to the third, I mean I times a times a times a 3 times, and then a times a 2 times, so a squared. Now when I multiply together, so I see how many a's in here. So I see 5 a's. So therefore the answer would a to the fifth. However, you would think, oh, that better way to do, I don't have to write this one many times. I can look at here. I get at the top, the exponent here, 3 plus 2, 5. So that would be the shortcut. So that they call the product rule with G like this. So if you have the same base, multiply together, you all do it, you add the exponent together. So you have the answer right there, right? So for this one over here, you can do it here, 3 to the second, 3 to the sixth, and 3, this invisible 1 right there. You can see that invisible 1 right here. Yeah, so this one have the power 1. You see right here, yeah. So what we have to do is they all have the same base. So therefore you get write 3, and you add the exponent together, that 2 plus 6 plus 1. So I have 3 to the 9. So that would be my simple answer for that one right there, right? So 3 to the 9, and then you can calculate that part. Yeah. So that's it for the first one that you have in there. Okay. And now we're going to move to the next one. So this one have more complicated, have all letters. So again, if it's the same, so you can put all together, the power together, and then you can compute that part. Now the quotient rule, so let's take a look at here. I have a to the fifth divided a to the second. That means a to the fifth, that means on top, I write 5 a's on top, and then 2 a's in the bottom. As you see that I can cancel the 2, right? So the answer, I have a to the third left, right? So therefore, this one over here, so the best way to do, I can take 5, I subtract 2. Then I have the answer. That makes it easier, right? So therefore, they have the next one, they have the product rule right here. So if the two of them same base, you divide, you will take the top, subtract the bottom. So you have that. That's for quotient rule. And then we're going to go down here. You have something called power rule. So what does that mean? So I have a to the second and the whole thing raised to the third power. So first I'm going to do a to the second times the third. That means I have a squared times a squared times a squared 3 times, right? And then we use the product rule earlier, we get add 2 plus 2 plus 2, so it equals 6. So therefore, you see that here, oh, instead of do this long thing, I can do the shortcut. I have 2 times 3 equals 6. So I have that one right there. Yeah. So therefore, the power rule over here, if I have the a's and I raise to the power, and then I raise power again, I multiply the power. So I have the power rule for that part. Okay, so with all the example we see earlier, so now we put all together, so we have a rule like this. So rule number 1, if I multiply two numbers have the same base, different exponent, that all I add the exponents together. And if I divide, then if they have the same base, then I can take the top, I subtract the bottom, I have the answer right here. Now, if I multiply, I take to the power of a power, then I multiply them together right here. And if I have a product, and then I take the power, then I can distribute the power into each form. So the product of a times b raised to power n would be a to the power n times b to power n. Same thing with the quotient rule. So if I have a divided by b, this quotient here, I raise to power n, then I can distribute n into, I have a to power n and then b to power n. Rule number 6, if I have any number, I raise to power 0. But with condition that a cannot be 0, then the answer is equal 1, always equal 1. Now, if I have negative exponent, then I can put it down 1 over a to the n. I have that part. And then if I have 1 over a to the negative n, the bottom, I can flip it over, I put it on top. So basically, whenever you have the negative exponent, if on the top, you put in the bottom, if on the bottom, you put on the top. So that's what they say right here, rule number 9. So we have that when we flip over a reciprocal. So the other property for exponent. So use this one to do all your homework.